Welcome back to our YouTube series on polymers we encounter in everyday life, where we highlight polymers used in healthcare and also safety applications.
In our most recent video, we discussed polymers used in dental applications, especially dental fillings.
Right, in this video, we're going to discuss some polymer adhesives used in healthcare, focusing on adhesives in wounds and bandage type applications.
So, where can our viewers expect to see adhesives in healthcare?
Yeah, it's a really good question. There's many different places we can expect to see polymer adhesive. Sometimes as part of the background infrastructure. So, for instance, we might need to stick different pieces together to make, say, a sailing bag or other equipment. In other cases, the actual adhesive might be directly applied to the body.
Right, and in the second case, the adhesive very well may be on the surface of the skin itself, or even in contact with a wound. And so, in those cases, safety becomes a critical factor.
Yeah, exactly. And so before we get into examples of adhesives used in healthcare, we should probably highlight the different types and functions of adhesives.
Right, there are many different types of adhesives on the market. Some are applicable in healthcare, and others are not.
Right. But if we break it down, what are sort of the main groups or types of adhesives used?
Well, there's two main classes of adhesives. One is pressure sensitive adhesives, and the other is structural adhesives.
Okay. So what are some of the differences between the two groups?
Well, pressure sensitive adhesives, as the name may suggest, are inherently sticky, and these bind to a surface when pressure is applied to them. On the other hand, structural adhesives actually bond or cure in order to form a solid that actually joins the two surfaces together.
Sure. And so pressure sensitive adhesives are generally not designed to carry any major forces or loads, whereas structural adhesives are actually designed to carry substantial loads.
So, let's think about what are some examples of each types of these adhesives that our viewers can think of.
Yeah, so something like a postage stamp or a printed label are good examples of pressure sensitive adhesives, or things like sticky tape. In this case, the sticky label, the sticky tapes, will stick to the cardboard box, or the postage stamp will stick to the envelope. But it isn't really hard to, remove the actual label.
Right. And on the other hand, two-part epoxy glue is an example of a structural adhesive. And it's really designed to stick two things together in more or less a permanent way, right? So that the adhesive actually maintains contact with those two pieces, even under what can be some pretty large forces.
Right. And those sort of epoxy type materials can really withstand some pretty substantial forces. So if we think of things like, carbon fiber bikes, those are actually an epoxy resin around a carbon fiber sheet.
Okay, so let's think about taking it back to healthcare. What are some examples of pressure-sensitive adhesives that are used in healthcare settings?
Yeah, there's obviously a lot of examples, but some pretty clear dominant systems we can think of are bandages and band-aids.
Right, that's a great example. So if we look at a Band-Aid, it has the outer wrapper that keeps the system sterile, and then there's the actual Band-Aid inside of that that has the that smooth backer on it, and that backer is chosen so that the adhesive doesn't stick to that backer very well.
Right, and that's what makes it very easy to peel off that backer. But the band-aid itself is actually designed to stick relatively well to human skin.
Right, and the majority of bandages that we encounter they're either made of a woven fabric or maybe a plastic film, really depending on the targeted application.
Yeah, so let's kind of ask ourselves, what is used to make the overall pressure-sensitive adhesive used in bandages?
Yeah, so it's a good consideration. So most pressure sensitive bandages are actually composed of an acrylic based resin. And these acrylic and other vinyl type monomers are polymerized together in order to make a larger polymer.
Right. What sort of molecules or monomers are actually used in these sorts of adhesives?
Well, as mentioned just a moment ago, acrylic groups really do tend to dominate the adhesive bandage industry, at least currently. And components such as butyl acrylate, shown in pink, uh, to being part of the polymer, ethyl hexyl acrylate, shown in red, and then other components such as acrylic acid, which we have shown in green, or vinyl acetate, shown in blue. There are also other types of components that are added to keep the material together, and these units can actually link or make those polymers larger.
Okay, so what do each of those components do?
Well, the main components of either butyl or ethyl hexyl acrylate actually give the stickiness to the material, and then the other components change the physical properties. They can help with the balance of stability or adhesion properties within the material.
Yeah, so I guess the interesting thing is that, people always talk about band-aids, being a little bit painful, when they're being removed. So what actually causes that pain when someone actually needs to remove a band-aid
Yeah,
from?
well, actually, thinking about actually ripping that band-aid off, it really has less to do with the skin, and it really has more to do with pulling hairs out at the same time that the adhesive actually comes off.
Okay, so that's the reason. Is there any evidence to support sort of fast versus slow peeling of a bandage?
Yeah, well, there have been studies performed, and they generally agree with what we already know, just from common experience, and that really it's the fast removal of a bandage actually leads to less pain than a slow, sort of drawn out removal. And there's a number of factors, but it really does seem to be that the fast removal does tend to be less painful.
Yeah, that's really fascinating.
So there's other classes of this other class of adhesives that we've talked about above, right? This set of structural adhesives we mentioned earlier. Are there any applications of those in healthcare?
Yeah, there's quite a few examples of structural adhesives in healthcare settings. Um, Maybe one of the more interesting ones is actually the use of cyanoacrylates, and these are actually some of the derivatives used in superglue to seal some pretty large wounds. Right? It can also actually be used to, cover abrasions used developed on the skin. So, for instance, rock climbers will often put a little bit of cyanoacrylate type materials as they, receive scrapes climbing a wall.
Right, and so in a number of cases, instead of using stitches, some moderately sized wounds can be treated with superglue, and it's kind of funny because you think about using superglue. We all really know someone here or there who has actually superglued their fingers together, right? And here we can use that same property in a treatment. However, we do want to caution our viewers that they should be careful and not try to treat themselves with store-bought superglue if they themselves or others they know get injured. And it's important to seek knowledgeable medical care in those cases.
Yeah, there are of course some limitations. In many cases, severe injuries or surgeries still need stitches, but moderately, sized wounds can actually be treated effectively using superglue.
And it's really interesting. So thinking about these superglue like materials, what are the components of these types of adhesives?
Yeah, so superglue and the medical versions are based on cyanoacrylates. They actually have some similarities to the acrylates we talked about in sort of the regular, pressure sensitive type adhesives.
Yeah, one of the really interesting things here is that the adhesive that's sold is sold as a small molecule which freely flows and actually adapts to the surface such as the skin. But in the presence of water, such as let's say moisture on the skin, the glue actually polymerizes and forms these long, strong polymer molecules like the ones shown on the slide. So this example is 2-octyl cyanoacrylate, and it's actually the first one that was approved for medical use. And it's that process that is actually how that structural adhesive is formed. And it makes a material that's pretty strong when you actually start from a very smoothly flowing solution. And as you know, when people superglue their fingers together, the that material is quite strong and is actually pretty persistent.
Yeah, and actually, of course, when the wounds heal and the cells regenerate, the adhesive should fall off.
Right. It's really, really interesting. Now, we hope that our viewers have enjoyed this episode on polymer adhesives and all their uses and differences, and really, those types of adhesives that we can use in healthcare.
Yeah, and stay tuned as our next video covers sutures, which actually ties in pretty well with adhesives. But until then, thanks a lot, and we'll see you soon.
Right.